name is Ogo, and in this tutorial we're going to be learning how to implement a RAM buffer for our 8x8 LED matrix. I want you to pace with me as I show you the different steps and how to go about it. First, a buffer is a region of physical memory storage used to temporarily store data. So that's what a buffer is. Next, I'll just talk about the two buffer filling techniques. There are basically two buffer filling techniques. The first technique is what I call a static buffer filling technique. Okay, and the second technique is what I call a dynamic or automatic buffer filling technique. So basically we're going to be looking at for this project we're going to be implementing a static buffer filling technique, and the static buffer filling technique involves implementing our LED matrix character segments, okay, manually on our buffer location or our RAM location, and we're going to be doing it manually. I'm going to show you the difference briefly, and let me just quickly talk about the dynamic or automatic buffer filling technique. In this technique, basically what happens is if we the Arduino would receive ASCII character text, maybe like a simple word like hello, and what it does is that once it receives hello, the Arduino is able to search and able to begin to fill the character segment and pick up the respective character segments for H, for E, for L, and O, and it automatically fills the RAM buffer location, and it's done automatically. That's what it means for dynamic. But for static involves you doing that manually by yourself, and it's quite more. It's actually much. It's not as easy as the dynamic, but we still get the same effect when we get to implement it on the 8x8 LED matrix. We get to have a scrolling message on our 8x8 LED matrix. So I'll just walk you through the different steps and in implementing a static buffer filling technique. In a future tutorial, probably the next tutorial, we're going to be looking at how to implement a dynamic buffer filling technique. Alright, so in understanding a static buffer filling technique, I'll just use a simple illustration using, for example, the character C. And in our previous tutorial, tutorial 5, I'd actually explained how to go about generating our character segment bytes. So, but it will be done properly in the next tutorial, in the next part of this video, so you can go through it. So, but I'll just show you. So imagine this particular box, or let's call it, assuming it's a big loaf of bread, and we're going to cut this into several slices. We're going to do a slice like so, 3, 4, 5. Okay, 1, 2, 3, 4, 5, and 6. So okay, so and we're going to generate the respective bytes. Now just think of these things as this whole big character C, and we're dividing them into several slices. So would say for this first slice is going to be 83 hexadecimal. This next slice will be 7D hexadecimal. This one is 7D hexadecimal, 7D hexadecimal, and this is hexadecimal, and the last one we'll call it FF hexadecimal. So we have 83, 7D, 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 BB, FF, all hexadecimal. So we're going to actually look at how to implement this in our memory, that is in our buffer for the Arduino Uno. So here we have an example of how our memory location looks like for our Arduino, and I've actually separated some bytes, and I've called them display region, and I've called this other part, I've called it the undisplayed region. Now for the display region, we've specified 8 bytes or 8 locations, and this is 1, 2, 3, 4, 5, 6, 7, 8. The reason why we have only 8 of them for the display region is because we're actually looking at an 8 by 8 LED matrix. So for the memory locations which we are going to interface to the which we are going to display in the memory for our 8 by 8 LED matrix, we have to only use 8. Now if we're using more, let's say we wanted to do like 8 by 64, it means that the number of display region will have to increase to about 64. So that's the reason why we are using 8, just because we are using only 8 locations for our 8 by 8 LED matrix. So the whole idea of what we want to do next is to fill the undisplay region with bytes of the C character, and we want to fill this region and we want to scroll or shift the bytes into the display region, and this will give us the effect of actually the character C scrolling out. So what I'll just do now is that I'll just go ahead and I'll fill the display region with the bytes for the character C. Okay, so I'm going to put here 83H hexadecimal, 7D hexadecimal, 7D hexadecimal, 7D hexadecimal, then we have BB hexadecimal, and we have FF hexadecimal. So what we actually want to do is okay, at this point what I'm going to do is that I'm going to change the orientation for the our buffer, our memory location, so that we'll get a better understanding. And I'll just do that quickly so that you get to appreciate the static buffer filling technique. What we have just done here is that I've actually changed the orientation of the view for our memory location. So just think of this as a portrait view, and this new view as a landscape view. Actually, this is actually the correct perspective, the correct view we should, the way we should look at our 8 by 8 LED matrix, especially when we subsequently when we're going to be looking at in our longer displays. Maybe we want to do an 8 by 64 or something longer than that. So this is usually the correct view or perspective we should see our memory location. So that's why we've just done that, so for clarity of explanation. Alright, so we are looking at static buffer filling technique, and what you've just seen me do here is that I have manually filled the buffer locations with the character segments for C, and which will fill here 83, 7D, 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 BB, FF. Now that is just the whole idea for static buffer filling technique. You have to do it yourself. You have to think of this undisplayed region. Imagine if it were longer, it's just for space. That's why we are just using this number of locations for the undisplayed region. So think of this undisplayed region as let's say we have about 60 more bytes, and you have to now manually fill the buffer locations with your character segment bytes, and you have to do that. So if you have like you want to display hello world on your 8 by 8 LED matrix, for example, it means that you have to enter for H, you have to enter maybe about 6 bytes character segments for your H character, and for E as well, you have to enter for E as well the different about 6 more bytes, and for L and so on that way. So that's just the idea for static buffer filling technique, and I already mentioned that in another tutorial we're going to look at dynamic buffer filling technique, where we get to do this automatically, and we don't need to bother about writing this by hand or filling this or coding it manually to the Arduino memory locations. So you get to do that dynamically in that particular tutorial. So in this tutorial, I've just explained what is involved in static buffer filling technique, and I explained that you have to do that manually. So in this case now, if we can now use a shift instruction, okay, we can use a shift instruction or a rotate instruction that will help us get to rotate one by one, okay, and we can rotate from the displayed region, and we get to keep on rotating into the display region. And what we're going to get, the effect is that we're going to see the character C scrolling into the display region, and we can keep on shifting one at a time, rotating one location at a time, and the repeated effect is what we get to see is the C character scrolling out from the undisplayed region to the display region. So if we have other interesting words we want to display with 8x8 LED matrix, all we need to do is that we get our character segments bytes for the different characters for the word that we want to display, and we'll get to manually fill it into the undisplayed region, that's statically, and we have to now use a shift instruction to rotate it into the display region and on like that, and that display gives us the scrolling effect. So, and that's just the whole basic idea of the static buffer filling technique.